Dear students, in today's class, I am going to start a new chapter titled Motion in a Straight Line. And in this chapter, we are going to learn all about the motion of a body along a straight line. As you can see in this animation, a car moves along a straight line. An athlete running along a 100-meter track, or a freely falling body. So, these are all example for motion of a body along a straight line. Now, before understanding this entire chapter, so first learn some of the terms like rest and the motion. So, what do you mean by rest? What do you mean by motion? So, these are all terms which are very much familiar, you have learnt in your lower classes, but we are going to just revise all these terms again. Now, when do we say that a body is at rest? A body is said to be at rest when there is no change in position with respect to time and the surrounding. Okay. So, here we have a table, and on the table I am going to place an object. And if that object you will find for a longer time, then we say that there is no change in position of the object which is placed on the table. Then we say that this object is said to be at rest. There is no change in position with respect to time and the surrounding. Surrounding means anything around. For example, a room acts as the surrounding. An observer inside the room acts as the surrounding. Okay. So, when do we say that a body is at rest? A body is said to be at rest if there is no change in position with respect to time and surrounding, is called as rest. When do we say that a body is in motion? A body is said to be in motion if there is change in position, if there is change in position with respect to time and the surrounding, then we say that the body is said to be in a motion. Okay. So, in the previous diagram you can see here the car is in motion. You know why? Because the car is changing its position. As the time changes, the car is changing its position. Now, you can say that this car is in motion. So, hope you have understood the two terms, rest and the motion. Okay. Now, can a body be at rest as well as in motion? Can a body be at rest as well as in motion? And the answer is yes. Now, how can a body be at rest as well as in motion? So, good example that if you are you are traveling in a bus, okay, and there is a driver seated and the vehicle is moving, let us consider in this particular road. Okay. And now, with respect to you, there is no change in position of the driver. So, therefore, the driver is at rest with respect to you. But for an observer standing on the road, the driver is in motion. So, therefore, with respect to two different observers, a body can be at rest as well as in motion. So, hope you have understood the term. So, a body can be at rest as well as in motion, but only with respect to two different observers. Okay. Just look at this diagram. So, in this case, you can imagine yourself at rest and all the other objects around you are in motion, correct? See, as you are traveling, don't you get to see like the electric poles and the trees are going away from you. So, that is called the relative motion, where you can assume yourself to be at rest and all the objects around you are in motion, or you can even assume yourself in motion assuming the other objects around you are at rest. Now, that is called as the relative motion. So, as you can see in this diagram, you get to see that all the the boundaries of the road, they are going away from you, as if they are moving. So that is what we call the relative motion. So you can assume yourself at rest and all the objects around you are in motion, or you are in motion and all the objects around you are at rest. So hope you understood the term, the rest and the motion. So can a body be at rest as well as in motion simultaneously? And just now I have answered it, and the answer to that is yes, with respect to two different observers. When will a cyclist appear to be at rest with respect to another moving cyclist? When will a cyclist appear to be at rest with respect to another moving cyclist? So what is the answer to this? The answer is when both the cyclists move in the same direction with same speed. When they move along the same direction with the same speed, then we can say that one is at rest with respect to another, because there is no change in position with respect to each other, right? You can see that their separation remains the same, the distance between them remains the same. So therefore, the answer to this question, when will a cyclist appear to be at rest with respect to another moving cyclist? When both move along the same direction with the same speed. So that is the answer to this particular question. So we are going to introduce a new term called scalars and vectors. So what are scalars and vectors? So important term. So scalars are the quantities having only magnitude. Physical quantities having only magnitude are called scalars. Example, all the fundamental quantities are fundamental, okay? Fundamental quantities are example for scalar. Very easily you can remember, what are the fundamental quantities. There are 7 fundamental quantities, right? That is mass, length, time, and then remember the word late, correct? It stands for L, luminous intensity, A, amount of substance, T, temperature, and E is electric current. So example for scalars, all the fundamental quantities. And what are scalars? Quantities having only magnitude. What do you mean by magnitude? Magnitude means the value of it, okay? Value. After measuring, we get some number, right? That's called magnitude, okay? And after writing the magnitude, there may or may not be any unit. So unit will be there always to identify the quantities. If it is mass, kilogram. If it is length, in meter. If it is time, second, and so on. Clear? So with the help of the magnitude and the unit, we can completely understand that particular quantity, and such quantities are called as scalars. So what are scalars? Quantities, physical quantities having only magnitude are called scalar quantities. Now what are vectors? Quantities having both magnitude and direction, which means that to understand this particular physical quantity completely, not only magnitude, but we need even the direction of that particular quantity, and such quantities are called as vector quantities. So physical quantities having magnitude and direction are called vectors. Example, I am going to give a simple and easy example. Displacement, velocity, acceleration. Along with the velocity you can remember momentum, and along with the acceleration you can remember force. There are many other vector quantities are there, okay, but you do remember only these, okay, because they'll ask question in the exam. So like give an example for vector quantity. In such case you need to remember. So which are 5 vectors? 1, displacement, velocity and momentum, acceleration and force. I am going to stop these example, but once we learn more and more physical quantities, I am going to tell whether they are scalars or vectors. Okay. So, what are scalar quantities? Quantities having only magnitude are called scalars, and physical quantities having both magnitude and directions are called vector quantities, and all fundamental quantities are example for scalars, and we have 5 easy example for vector quantities. Okay. So, this question has appeared in year 2014, so definitely an important question. Okay. Right. So, now let us learn slowly one by one terms associated with motion of a body along a straight line, and 2 important terms are distance and displacement. They are not same. Okay. And to understand this, let us check this animation. So, here we have an insect which starts from A, and then you can see it moves like this in this path, and then like this, and then it goes like this, and then finally it reaches the point B, correct? So, you can check once again. So, we will make the insect to move again. So, this is how it moves on a surface and then it reaches B. Okay. So, we have the term distance, and then we have the term displacement. So, are these 2 terms same? Yes, they are not. They are not the same terms. Okay, right. Then what is the difference? What is distance? So, distance is nothing but the length of the path covered. So, what is distance? The length of the path covered is called as the distance. What is displacement? Displacement is the shortest distance between initial and final point. Shortest distance between the initial and the final point is called as the displacement. Okay. So, what is the distance? The length of the path covered is called as the distance. So, this is the length of the path. See, this is the length path, right? So, this is the, that is the distance. And what is the displacement? Shortest distance between the initial and the final point. So, this is the initial point. The final point is here, correct? So, which is the shortest distance? You can see one arrow is there. See, this is the shortest distance. That is called the displacement. Okay. So, therefore, in this particular diagram, if you look at this animation, which is more, distance or displacement? What do you think the answer for that? Which is greater, distance or the displacement? So, definitely you can answer that very easily. Distance is greater than the displacement, correct? Distance is always greater than displacement, correct? But what if this insect moves straight away like this, from A to B? What if it moves, instead of moving in a curved path like this, what if it moves along a straight line? In that case, both the distance and displacements are equal. So, that is why we say that the conclusion is distance is always greater than or equal to the displacement. So, when distance and displacement are equal, when the body moves along a straight line, both distance and displacement are equal. Okay, right. What is the symbol used for the distance? The symbol used for the distance is S. Even for the displacement also we use the symbol S only. Sometimes instead of S we use the symbol X. Okay, X is another symbol used for the change in the position or for the displacement. So, therefore, there are 2 symbols are used, either S or X. Okay. The next point comes length of the path covered. So, therefore, what is the unit for both? So, unit for both, SI unit, I am talking about SI unit. The SI unit is a meter. So, distance is measured in meter, displacement is also measured in meter. Okay. Then comes what is the dimensional formula of that? Dimensional formula, it's a measure of length, right? So therefore the dimensional formula is L. And distance is nothing but length of the path covered, like this. This is the length. And you can see in this case, there is a continuous change in the direction, right? So distance is a scalar quantity, whereas displacement is a vector quantity. Why it's a vector? Because shortest distance between the initial and final point. That means we measure the distance along a particular direction, correct? Understood? We measure. Displacement means from the shortest point to the final point. See, it's in a particular direction. So that's why displacement is a vector quantity, whereas the distance is a scalar quantity. Here, it depends on path. Distance depends on the path, whereas this is independent, doesn't depend, independent of the path covered. So whatever may be the path covered, it is always the shortest distance between the initial and the final point. Okay. For example, if a body moves in an semicircular path like this, okay, then this is the distance traveled. What is semicircular? It's a pi r, because 2 pi r is the circumference, half of the circumference, which is pi r. Pi r is the distance. What is the displacement? This is the displacement. How much is this? This is nothing but the diameter. What is diameter? Just twice the radius. So 2r is the displacement, pi r is the distance traveled. So hope you have understood the difference between the distance and the displacement. There are 3 points. Important question, repeatedly asked in the examination. Okay. So hope you are clear with these 2 terms, distance and displacement. Okay. So let's take one more animation and then we'll find out as what's going on in this particular case. So a man starts from 0 here. This is 0. Okay. And then he moves along a straight line. Let's see, he starts from 0 and then he walks like this, 2 meter and then 4 meter and then he comes and stops here, 6 meter, correct? So what is the initial position? 0. What is the final position? 6. So what is the displacement? 6 meter. In which direction? In this particular direction, correct? So it's a vector quantity. So what about the distance and displacement? In this case, both distance and displacement are equal. Why? Because the man is moving along a straight line. So hope you have understood as how we can find the displacement. So basically we need the initial position, we need the final position. Imagine if the initial position is 6 meter, the final position is 12 meter. Initial position, okay, final position. So what is the displacement? Final minus initial, okay, 12 minus 6, which is 6 meters. This is how we can find the displacement, okay. Right. So the question that has appeared 4 times in the examination, and the question is distinguish between distance and displacement. I have already given 3 points. This is what you need to write in the examination, okay. Distinguish means find the differences. What are the differences between distance and the displacement? So what is the distance? It is the length of the path covered by the body is called distance, and the shortest distance between the initial and the final point is called displacement. Distance is a scalar quantity, displacement is a vector quantity. Distance is depends on the path, whereas displacement is independent of the path covered by the body. Can the displacement of a moving particle be 0? What do you think the answer for this? Yes or no? Can the displacement of a moving particle be 0? And the answer is yes. Now, how can the displacement of a moving particle be 0? So, this is a good example. A body moves in a circular path, okay? It starts from here, A, and then it moves like this, and then comes like this, and then again back to the same point. Can the displacement of a moving particle? Yes, the particle is moving. And how it becomes 0? Because the initial position and the final position, initial point and the final point are same. So, when the initial point and the final point are same, then there is no displacement, correct? Because what is displacement? After all, it's the shortest distance between the initial point and the final point. But the initial point and the final point is same. So, there is no displacement. Displacement is 0, and that is what the answer. So, can the displacement of moving particle be 0? The answer is yes. Good example is a body moving in a circular path, or when a body moves in one circular path, and when it completes one circle or two circle or three circular path, it should come back to that same original point. In that case, the displacement will be 0. Okay, by the way, what is the distance travel? Distance travel is length of one circle, which is circumference. So 2 pi r is the distance traveled by the body. Hope you have understood. So, let us try one more question. So, go through the statement of this particular question. The statement is, a body moves 10 km towards the north. Okay. So, first let me mark the direction. So, this is the east and the west. So, this is the north, this is the south. Okay. Now, whatever the direction which I have marked here is in an horizontal plane, students. Okay, keep in mind. So, if this is east, and this will be west. Okay. East, west, and this will be north like this, okay, and the south will be back. It's not, north is not upward, south is not downward. So, this is on the board we draw like this. So, north doesn't mean that the north will be like this, south will be down inside the earth. No, it's in the horizontal plane, okay. So, that's what you need to understand, right. So, a body moves 10 km towards the north. So, that's what I'm doing, right. So, this is a 10 km. North, and 40 km towards the west. So, like this is 40 km, 40 km towards west, and finally moves 40 km towards the south. So, further 40 km. Okay, so this is 40 km towards south. Find the net displacement and the distance travelled by the body. So, what is the displacement? Displacement is the shortest distance between the initial point and the final point. So, this is the displacement, and I want to find this. Okay. Now, if this is 10, if this is 10, this also has to be 10, right? This is 10. But total here is a 40. See, this is 40. Correct? If that is 40, how much is this? 10 over remaining, how much? 30 kilometers. So, this is 30. Correct? This is 30 kilometers. Hope you are able to see that particular diagram. That's 30. If that is 30, how much is this? This is 40 kilometers. So, this is a 40, this is a 30. How do you find this? That is a right angle triangle. You can use a Pythagoras theorem, right? So, displacement is this. Displacement is equal to square root of 40 square plus 30 square. What is 40 square? 1600 plus 30 square 900. How much is that? That's 2500. What is the square root of 2500? That is a 50. So, 50 kilometer is the displacement. So, hope you have understood how we can find the displacement very easily. because displacement is always the shortest distance between the initial and the final point. Okay. How about the distance traveled? The distance traveled is nothing but the length of the path. You have to just add them. 10 plus 40, correct, plus further 40. So that will be 90 kilometer. So you can see in this case distance is always greater than the displacement. Why? Because the body moves here in a random path, not along the straight line. Only if it moves along straight line, then the displacement and the distance will be equal. Okay, right. So that's about an important term, which is the distance and displacement. So we have next two terms again, which are very important. The term is speed and velocity. Speed and velocity. So whenever there is a change in position of a body from one point to another point, definitely it takes certain time, correct? So let me again give an illustration where a body moves from A to B. A to B. This is 10 meter. The first person covers this 10 meter in 1 second. The next person covers the 10 meter in 2 seconds. So who is moving faster? Who has covered that distance in lesser time? So therefore, to understand how fast an object is moving, a particle is moving, a body is moving, we define an important term called speed and velocity. So the purpose of measuring speed and velocity, to know how fast an object is moving. So that's how we measure it. By measuring the speed of a body, we have learned, there are different events are there, correct? So especially the track event, where we try to find who is the fastest man on the earth by measuring the distance traveled, which we know it's a fixed, like 100 meter, 200 meter, and then we measure the time taken to cover the distance, and then we measure an important term called speed. So therefore, what this is a speed and velocity measures. It basically measures how fast an object is moving. So how to measure the speed and velocity? Speed is defined as a rate of distance traveled or distance covered, a rate of distance traveled or rate of distance is called the speed. Then what is velocity? A rate of displacement is called velocity. So rate of distance is called speed and rate of displacement is called velocity. Now what is the meaning of the term rate? Here we use the word rate with respect to time, how fast. So what we are supposed to do whenever we use the word rate. So I'll write here the speed is equal to, rate means always with respect to time, that means we need to divide by the time. So therefore speed is always distance divided by the time, whereas velocity is always is equal to displacement divided by the time. Okay. So this is the meaning of the word rate of distance traveled. Rate means always with respect to time. Okay. So rate of distance traveled is called speed. A rate of displacement is called as velocity. And from this we can very easily understand that distance is a scalar, time is a scalar. That's why speed is a scalar quantity. Okay. Velocity is a vector. Time is a scalar. When you divide a vector by a scalar, you will get a vector quantity. So that's why velocity is a vector quantity. And since speed is scalar, velocity is always positive. Scalar quantity here, speed, which is always a positive. Speed can never be negative. Whereas velocity can be either positive or negative, or it can be 0. Okay? Because a vector quantity can be positive, or it can be negative, or it can be even 0. We have already learned that displacement of a moving body can be 0, right? When a body moves in a circular path, what is the displacement? It's a 0. When the displacement is 0, what is its net velocity? That is also equal to 0. So these are the four important differences between the speed and the velocity. So how do we measure speed? A rate of distance is called speed, whereas the rate of displacement is called velocity. Speed is distance by time, velocity is a displacement by time. Distance is a scalar, that's why speed is a scalar. Displacement is a vector, that's why velocity is a vector quantity. And a scalar quantity is always positive, whereas vector is either positive or negative or 0. Again, an important question from the exam point of view. Distinguish between speed and velocity. You can see this is a question that has appeared in the year 2016, and these are the differences which you need to write from the exam point of view. So basically, speed and velocity. Again, speed is always, just like distance is always greater than or equal to the displacement. Similarly, speed is also always greater than or equal to the velocity. And when speed is equal to the velocity, when the body moves along a straight line, the speed is always equal to velocity. Otherwise, the speed is always greater than or equal to the velocity. The next few terms we are going to learn related to the speed and the velocity. The first term is uniform speed or uniform velocity. Let's consider a body moves along a straight line, and if it covers 10 meter in 1 second, again if it covers the next 10 meter in 1 second, again it covers the 10 meter in 1 second. So here we find the body covers equal distances in equal interval of time, correct? The body covers equal distances in equal intervals of time. So let's find the velocity. Let's find the speed. How do you find the speed here? Distance traveled. First, let me take only this part. Distance traveled is 10. Time taken is 1. So, what is the value? It's a 10. So, when I write 10, the question comes, so what is the unit and what is the dimensional formula? Speed is nothing but the distance traveled. The distance traveled is measured in meter, divided by time taken. Time is measured in seconds. So therefore, keep in mind that meter per second is the unit of speed as well as the velocity. And we already know the dimensional formula of it. We have learnt already. Meter per second. Meter, it's a measure of length, L. Second time, it's a measure of time, means the symbol used for that is a T. So therefore, LT minus 1 is the dimensional formula of both speed and velocity. So what is the SI unit? Meter per second is the SI unit of both speed and velocity. And what is the dimensional formula? LT minus 1 is the dimensional formula of both speed and velocity. Very important, so keep that in mind. Now here we find that the speed of the body after covering 1 second is 10 meter per second. Let me take this much now. Okay, what is the total distance covered? 20. I will measure here, that's equal to 20. Divide by, what is the total time taken? 1 plus 1, that's a 2. 20 by 2 is how much? It's a 10 meter per second. Now you take entire distance, 30 meter in 3 seconds. So find the speed again, 30 meter by 3 seconds. So we'll get 10 meter per second. So look at the value that we got. Whether you measure this distance or whether you measure the entire distance, the value of the speed remains the same or what? Uniform. So uniform means the same speed, same value. So when do we say that a body moves with uniform speed? A body is said to move with uniform speed if it covers equal distances in equal interval of time. Then its speed is said to be uniform. So when the speed is said to be uniform, if a body covers equal distances in equal intervals of time, then its speed is said to be uniform. Now what is the definition of uniform velocity? If in the place of distance you replace that by displacement, equal displacement in equal intervals of time. Okay. So if a body undergoes equal displacement in equal intervals of time, then its velocity is said to be uniform. You understood the difference? Same thing in this case, both speed and velocity are uniform. You know why? Because the body moves along a straight line, and when the body moves along the straight line, its speed and velocity has to be same, and we find that here not only distance but displacement is also same, correct? So if a body covers equal distances in equal intervals of time, then its speed is said to be uniform. And if a body undergoes equal displacement in equal intervals of time, then its velocity is said to be uniform. So hope you have understood the differences between the term distance displacement, then speed and velocity. So what is the SI unit of speed and velocity? Meter per second. What is the dimensional formula of speed and velocity? LT minus 1. So I am going to continue the rest of the topic in the next class. We are going to learn a lot of very important basic terms, okay, so which are useful in other chapters too, okay, right. So do revise this topic and then start writing in your notes if at all you have not started. So I will catch you in the next class. Thank you.